hopefully all of you remembered to bring your graphing calculators today. You guys got those? Pull them out of somewhere. You don't have yours? All right, everybody have theirs out? Okay. We are going to take a look at 8.6 and 8.7 using your graphing calculator instead of doing what Hawks is asking you to do in there. And Hawks is asking you to solve all these separately. So for 8.6 and 8.7, we're going to go through and get your graphing calculator set up for the matrices in there, and go through and get that in place. So what you're going to do first is you're going to grab your graphing calculator, and let me see if we can make this a little bit larger in here. We can see a little bit better. So first off, you're going to get your graphing calculator, and it should have, you're going to need your second key in most cases if you have a TI-83 or 84. Set up your matrices in your calculator, and again, once this is set up, you don't have to do this ever again. Okay? So where we're going to go first off within this is you're going to find your matrix button. Everybody find that? It's usually a second, and it is above, let me see. Above the x to the negative first power is where your matrix button is at. So you're going to go there, you're going to hit that button, you're going to go over to edit. At the top it'll have number, edit, and math, or no, it's names, names, math, and edit. There we go. So you're going to go over with your over arrow to get to edit. And when that comes up, it's going to show you down below a whole listing of A through, I don't know, F or G, somewhere around in there. We're going to go to letter A, and we're going to set up, and it's going to pop up on your screen, and it's going to show in that screen the pieces that you need there to do your edit. And so you're going to go over, and you're going to enter 2. So type a 2, enter, 3, enter, and then we're going to quit. And if you notice below, it set up a matrix under there that has a dot or spaces, and a space, and a space, and a space. So this is what's known as a 2 by 3 matrix. These are the ones we've been solving so far in the other parts of chapter 8 with that. Next, you're going to get out of there. Then you're going to go back to matrix again, over to edit. But now we're going to go down to B instead. So down to B. So everybody go down to B. So use your down arrow, and it'll go down to B. So when you get down to B, you are going to hit 3, enter, 4, enter, and then you're going to go second and quit. We okay so far? No? No, you see. Anybody else need help with that?
Yeah.
Yeah? Okay. If you're not in matrix, it won't get you at the right spot either.
Okay, so
Second, matrix, over to edit, hit enter, then hit 2, enter, 3, enter, and quit, second quit. Then go second matrix, over to edit, go down to B, hit enter, and then go 3, enter, 4, enter.
second quote?
Yep. Everybody there? Do we all have our matrix stuff set up? You think so? Okay. Because what it looks like, and you don't have your 3 by 4 in your B.
I have it from last semester.
Yeah, you do.
And I don't know how to change it, so I just leave it like that. I go down to C when I
Oh,
read it.
okay.
I
I
have it.
want one that has a B. B. You use yours. When you're in your calculator, this is what you should end up seeing when you're at that point. We went over to edit. We went down to the first one of A, hit enter, and that's what you should have on your calculator. Oh, it was showing up.
There you go. I can see.
Right there? That looks like a good spot. But this is what you should see when you're in a 2 by 3 matrix. Okay? And under there you've got zeros for each of these. Notice there's a row here and a row there. This is your first equation. This one's your second equation. Okay? And so that's our pieces that we end up having for that. Now we went and we said second quit, and then we went second matrix, which is above your x to the first power, went over to edit, went down one, and we ended up in our second matrix, which looks like so, which is a 3 by 4. Okay? And because it's a 3 by 4, there are 3 rows, and if you go down here and you get to that row and you scroll across, you are going to see that there are 4 values that are running across the page. Okay? Are you ready with that part? We all there now? Okay, good. So, I have a second quit. I end up getting my piece in there. All right? Now, what we're going to do is once you get to this point, you don't ever have to go back and redo that. That's going to be on your calculator until you take out your major battery in there, or you go and reset your calculator. Then it'll wipe it out, but otherwise it should be there. So once you've decided whether you have a 2 by 3, which is 2 equations, 3 terms in each, or a 3 by 4, which is 3 equations and 4 terms in each. So a 2 equation looks like so. A 3 equation looks like so. All right, we okay with that part? We've been working with these so far. That's what our problems have been, and we've been using substitution and the addition principle to solve these, because we've been going through and wiping out y's, all right, getting what x's should be, and then calculating what our values should be on those. So what we're going to do is we're going to take this problem right here, that one, and we're going to stick it on our calculators. So what we got to do is you're going to go to matrix on your calculator, and then go to over to edit, just like we did before. So are we there? Okay. Then we're going to go down to B, because B is our 3 by 4 matrix. You okay with that part? Okay. Now what that is doing inside of there, and in Hawks in 8.7, it's going to ask you for what is the augmented matrix. And the augmented matrix is the first number in front of each of your letters, and the answer, the answer that you have is placed in a pattern that you happen to see. And so that pattern is 2, -3, -1, -4, and they put a dotted line in between here so that you know that you have an answer is to the right, all of your numbers are to the left. The x's, the y's, and the z's hold all of these different categories and different spots in there. So then the next one is a -1. The sign in front of it tells me the sign of the number. A +2, a +1, and a 6. And then the bottom one is a 1, a -1, a 2, and a 14. This is augmented. So if you run across in 8.7 something that asks you about an augmented matrix, that's what you have in there. Okay? So basically all you're doing is taking your numbers from up here and sticking those into that category. Now on your calculator, you're going to enter these same things, because this augmented matrix is what your calculator uses to solve this. So we went over to edit, and so when you go over to edit, we're going to go down to B, because I want a 3 by 4 matrix, hit enter, enter to get beyond the 3 and the 4, and enter one more time, and you should be at the first 0 level. Are we there? Okay. Then put my numbers in. So I'm going to go 2, enter, -3, enter, -1, enter, -4, enter. So your first line should be in. Your calculator will automatically hop down to the next line. Did it? Okay. Then it's -1, enter, 2, enter, 1, enter, 6, enter. Okay, so you have 2 lines in there. You got that in there? Okay. Then you'll go 1, enter, -1, enter, 2, enter, 14, enter. Okay, got that in there? All right. Now, before you ever do anything else with these, I can't stress this enough, go back and make sure you entered them correctly. So when you're in your calculator, and you may be over here to the 4th line, go in your calculator and take a look and see that you got stuff in there right. So I usually go down mine. So -4, 6, 14 on my calculator. Go over a line, -1, 1, 2. Go over a line, -3, 2, -1. Now I need to use my over arrows because this line's not showing on your calculator, right? So over arrow till it does show, and look and make sure you have 2, -1, and 1. We all have that in there? Now, again, take your time to do this. Your calculator will give you an answer regardless of what you put in. So if you go through and you work one of these out and you didn't check to make sure you put something in right, your calculator will give you an answer, and I can guarantee Hawks will tell you it's not right if you put something in wrong. Okay? So be really careful and make sure you take that extra time to double check it. All right, so we got that all in. Go second quit. And now we're back to our information that we happen to have in here. So we basically went down here to example 2 and we entered that information that's in there. And again, all X's are in the first column, all Y values are in the second column, and all Z's are in the third column. So again, double check. So I can't stress that enough to make sure you do that. Okay, now we are going to go to solve it, we are going to go to your matrix again. So that's second, the X to the first key. Everybody there? But now we're going to go over to math. So everybody to math, hopefully. Okay. And if we go back, and you are going to down arrow till you get to B. So down arrow, it's a ways down. You got a bunch of stuff to go through. Oh, use the up arrow to get there? Is it faster? Okay. All right, that's good to know. We can use our up arrow. And what you're going to find is when you get to B, you're going to have R, R, E, F.
Yeah, I don't have B either.
Sure?
Yeah.
You have to go to math.
I am in.
Did you go over to math?
Yeah, I am in math.
Not in math, it's in matrix under
Yeah,
math.
I'm in matrix and math. Yeah, I don't have it. Unless I missed it.
Right there is a B.
Oh, I was looking for.
Yeah, you got a B. You got to go back up to it, I think. Did you find it? Did you find it? Yes or no? Somebody not find it?
It's the letter
Hey,
It's
don't
the letter
worry.
B. Over to, no, you got the matrix.
I don't know if my directions were good enough or not. Do my text message.
Over to math. Then down. Okay, it's not the math button, it's under matrix. So you're going to go matrix to math. Jenna, did you find yours? Yeah. Okay. Mike, you find yours? It's on that on yours? This is you?
Come on.
Oh,
Me too. Come on. Yeah, I know. Usually has like 19 so or 11 to 19 so I
Oh, I was going to look at that.
Yep.
Two what?
Yeah, you have to go down. Everybody find it? matrix. All right, so catching up on calculators here. We're all there in the same point now? Okay. So now we've got that in there. So now go back to matrix. So go second matrix again. Leave it on names. Select B because we picked the B for where we put our matrix. Because now what we're doing is looking at where we put it at. Everybody get to B? Okay. And then you are going to hit enter. And it is going to put it on your calculator. It has something that looks like RREF. Then it has B. It's braces, I think. Is it braces or brackets? It's braces or parentheses? It's parentheses. Close it with another parenthesis. Hit enter. And below, you should have this as your answer. Everybody get that as the answer? Yes? No? Someone says no? Says no?
I'm in the game.
Okay. And then we're going to go second matrix to names and down to the okay. Now if I hit enter. Okay, anybody else have problems with that? Okay, now what does this tell me when I'm working with this problem? Remember, we put these in columns. The first column was X, the second column was Y, the third column was Z, and the fourth column was the answer. Okay? Yes? You're not there? Okay. Let me go take care of you.
Oh yeah. See, I'll leave this.
Okay. This videotaping is going to be a strange one today. Okay, so what's my answers? Well, X is equal to 4. Y is equal to 2. And Z is equal to 6. That make sense? Okay. So as you follow across those, the calculator did all that calculating for you and has solved that problem and has worked it out for you. So you've got all of your pieces happen to be in there. All right? Make sense? Hopefully. So the first column's x's, the y's are the third with these answers, and you've got your pieces in here that told you what your parts had to be. Now, there's a couple special things that can happen. So there are some special cases in here. And the special cases are where you have x is equal to 5, y is equal to 2, but z, notice there is no z. See that? There is no number in here at all. There's no 1, nothing represents it. In this case, you have many solutions to this problem. Remember we had those before, where if the two answers equaled each other, then we could say if there's no variables left, but the two values you were left with equaled each other, then we said we had many solutions, or infinite number of solutions. And so that same type of thing can happen with this. And so then the other one is where x is something, y is something, but when you get down here to z, there is no number for z, but there's a 3. This means that you have no solutions. So this is a no solution. Okay?
My high school teacher taught us that you need to have 3 ones in a row. Like tic-tac-toe.
Yes. Yep, 3 ones in a row. Yep. Yep, that's a good one too, because up here we have 3 ones in a row, so you get your tic-tac-toe winnings. Yeah. But down here, there's no winnings, okay? And down here, there's no winnings there either. But you got to be careful with that last number, because it's that last number that ends up indicating that for you, okay? So let's go and let's do some more of these so that we get an idea of what we do have to do. Pardon?
Why does it say 5 special cases?
Oh, it's number 5. Back here, 1, 2, 3, 4, it's the numbers on the page. That make more sense? No, there's not 5 special cases. There's only 2 special cases, okay? And so that's when those happen to pop up so that you can see what goes with that. Okay or not okay? What do we think? All right, let's do some more of these things on our calculators. So let me find some other examples here of what we can do with these. So here's one. Negative 2x minus 4y plus 5z is equal to a negative 2. 4x plus y minus 3z equals 4. And negative 6x plus 6y minus 3z is equal to a negative 6. So let's see what we can do on sticking those into our calculator to calculate out what our values would be for that. So we need it augmented, and the augmented is going to be negative 2, negative 4, 5, negative 2, 4, 1, negative 3, 4, negative 6, 6, negative 3, negative 6. And so then we can stick that onto our calculator, and let's see what pattern or what we come up with for that one.
What do we do if it's missing one? Do we put a 1 or
If it's missing something, you put a 0. You don't have that value, so if you got a missing y, let's say we didn't have a y here, you'd put a 0 to hold that position within that equation. Yep. Okay, so let's get it in there. You guys getting it stuck in there? So again, how did we do that? We went to second matrix. Then we went over to edit. So we're going to go over to edit. Then down to B. Hit enter. And what that does is pulls up that matrix. And then we're going to hit enter and enter to get beyond the 3 and the 4 in our calculator. And so as we do that, we got our space across there, and now you just start entering your numbers. So negative 2, enter, negative 4, enter, 5, enter, negative 2, enter. And that gets you to your next line. We're doing okay? Then I would type 4, enter, 1, enter, negative 3, enter, 4, enter. That'll be to my third line. Negative 6, enter, 6, enter, negative 3, enter, negative 6, enter. And what do I do now? Check it. Always, 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 because you can miss a negative sign very easily in these, and it'll mess your whole problem up. Okay? So, I double check it, go down. Negative 2, 4, negative 6, 5, negative 3, negative 3, negative 4, 1, 6, over arrow to get that first pattern in there, negative 2, 4, and negative 6. We good? Everybody got that? Okay. So now, the next step is go second, quit. Because I have to get out of that whole thing altogether. I can't just leave it there. And now I'm going to go second, matrix. Where to? Over to math. And down arrow to B. Now, we all know where B's at, right? Our poor calculators do have B in there. Okay. And then hit enter. Then go second matrix. Then down to B. That's the location of my matrix, so I have to go down to B and then hit enter. Close it with a parenthesis. Always make sure you close things. If you starts out with parenthesis, make sure you finish it with a parenthesis, because sometimes other things get thrown in and you don't always finish it off. And then after I close it with parenthesis, I'm going to hit enter, and my answer should pop up. So what's x equal to? 1. What's y equal to? And what is z equal to? 0. Okay. Now, to know whether it comes out true, we can always take these answers, the answers that we just found here. Is it many solutions?
I got 0, 0, 0, 0 all the way across.
All the way across the bottom? You got all zeros? So, we should have many solutions. How did I get a 0 right here?
I gotta put it on then.
Oh, maybe. I don't know. But you have to have a 1 in both of these locations. There isn't? Okay. And so your answer that you have on your calculator is 1, 0, 0, 1, and then 0, 1, 0, 0, and then 0, 0, 0, 0. Okay. What's a special? Okay. Yes. Many solutions. That's not what you have? That's what I have in my... Oh, yes. Yes, you have it. Your last line.
Oh,
The bottom
my
line.
first two lines weren't the same. I thought that was.
Oh, this part's not the same?
No.
What's this part?
1, 0, point, negative 5. The top one.
0.5?
1, 0,
Well, no,
negative point.
1, 0, 0, 0.5.
No, it's
1, 0,
1, 0, negative 0.5,
Oh.
and 1.
Oh, okay.
So
1, 0,
Negative
negative 0.5,
and 1.
1.
And then it's 0, 1,
Uh-huh.
negative 1, and 0. And then it's 0, 0, 0, 0.
Okay, you guys didn't go down and use B. You used A. No, you must have used A, because A will get you this answer. B should get you... Oh, you do? Okay. All right. Well, I guess it didn't, because it's a infinite number of solutions, I guess it didn't go through and solve it completely. So, yep, but it's infinite because this last line tells me it's infinite. Okay, let's do another one. Let's try this one. 4x minus 5y plus 5z equals a negative 5. 2x minus 6y plus 5z equals 5. negative 3x plus 7y minus 6z equals 3. And let that be my equation that I happen to have. And if we take that one and we augment it, that means we're going to put what we're going to put on our calculator. So this thing augmented is 4, negative 5, 5, negative 5, 2, negative 6, 5, 5, negative 3, 7, negative 6, 3. So that's what it would end up being. Okay, and then if I take it and put it on my calculator, I'll put it in just like I see it there. So work it out, see what you come up with for answers. Takes a little bit getting them in your calculator. A lot less time though than doing them by hand, let me tell you. It'll take you quite a while to get this thing done by hand. But always check, make sure you put it in your calculator correctly. Again, can't stress that enough. Because I've seen students go through and do these things and they get them wrong because they don't double check and left off a negative somewhere. So do your double check and make sure it's in correctly. So, anybody have an answer yet?
Yeah.
What is it?
X equals negative 35,
Mm-hmm.
Y equals 60, and Z equals 87.
Yep. Okay. Everybody agree with that?
Yep.
So it should look on your calculator something like 1, 0, 0, negative 35, 0, 1, 0, 60, and the last one is 0, 0, 1, 87. Okay? So that's what you should have on your calculator when you did that one. You okay? What do you think? Yes? Okay. So again, pay close attention to these things that are at the bottom so that you get that stuff and you know what you got going with those and what comes out of them. All right? Need to do another one? You okay? Another one? You all right? What do you guys think? Yes? You're fine? Okay. Now, they do end up putting in here with these, of course, story problems. As always. Of course, they gotta have story problems. So if you go back to your story problem sheet that you happen to have, the hardest part with these guys, it's not doing the math because we can go through and use our calculator to solve these, but we gotta come up with ways of setting them up. Alright, so let's see what we come up with to set this stuff up. So if we read the first one, a cash register contains $341 in $20, $5, and $2 bills. There are 28 bills in all, and 3 more $2 bills than $5 bills. How many bills of each kind are there? So what do we know?
Would be like X20 plus Y5.
So we're gonna assign them all a variable first, right? So 20 is gonna be X, 5 is gonna be Y, and 2 is gonna be Z. So if we do that, that helps us out. So 2 of our equations, one is connected right here, because if I have $341 in there, what does that mean?
They all them together equals the other one.
So 20X plus 5Y plus 2Z is going to equal 341. We okay with that one? Yes? Okay. There are 28 bills in all. What does that mean? What equals 28? Each one. X plus Y plus Z equals 28, so that's good. Remember, the X, Y, and Z are not the amounts of the bill, they're how many bills you have of that variety, okay? Then we get this last thing. It says that in all, and 3 more $2 bills than 5. What in the world does that mean? We've had those in our problems before. What in the world is that telling me?
5 equals 3 plus 3, y plus 3.
So y equals 3 plus z, or is it z equals z equals 3 plus y? You all got that? You okay with that part? Yes or no? Z, because Z's are $2 bills, and there's 3 more $2 bills than 5. So if I know how many $5 bills and I add 3 to it, I get my answer. My problem is I can't just stuff that underneath here. It's not written correctly. So I need to have all of my letters to the left and my numbers to the right, and so really I need to subtract a y from this side, so I get negative y plus z is equal to 3. Then I can stick that underneath here. So negative y plus z equals 3. So how many x's do I have in this whole piece, in this part right here? 0 of them. So I need to put a 0 there, because when I get the augmented piece of this that I have to put on my graphing calculator, I need to have a 0 going in there, or else I'm going to be in trouble. So let's stick that on your calculator. So it still is a 3 by 4, and so I still need to use b on my calculator. So let's see if we can put stuff in there and find out what x, y, and z happen to be.
So if it's X and Y and Z, is it just 1 or?
Yeah, right here. Yep, if you do not have a number up in front of those, there's a 1 in front of them. So there's always a 1 there with those. So yep, you have a 1. So are we getting to an answer?
I got.
What'd you get?
I got 15.
5 and 8.
Okay, who has the $20 bills? How many do I have of those? 15? Of the $5 bills, which is my y, how many of those do I have? 5. And my $2 bills? 8. Okay. Does it stand true? So 20 times 15, 5 times 5, and 8 times 2 should give me 341 if I did everything correctly. Okay? Double check, because if you entered something wrong, I would show you. Another thing that would show you did something wrong here is if you ever came up with a negative number for your answer at the tail end. You won't have any negatives in there. Okay. The next story problem. Local theater has 3 types of seats for Broadway plays. You have the main floor, the balcony, and the mezzanine. The main floor tickets are $58, balcony tickets are $49, and the mezzanine tickets are $34. One particular night, sales totaled $67,264. There were 370 more main floor tickets sold than balcony and mezzanine tickets combined, so we're going to read through it first. The number of balcony tickets sold is 42 more than 2 times the number of mezzanine tickets sold. How many of each type of ticket were sold? So we got to have the main floor. What do we want to call it? Yep. What do we want to call it if it's got the main floor?
X.
Want me to label it X, or do we want to call it F?
All that.
Because it might have some more meaning to us if I put something in there. The balcony we're going to label it B. And the mezzanine, we're going to label it M, okay? It helps sometimes when you're doing these to have some meaning to your letters. If you get X, Y's, and Z's in there, sometimes you get all done and you're like, wait a minute, what one did I mean? Another thing that having letters in here that makes sense, when you get to this whole big piece down here of adding and subtracting and doing all that kind of stuff, you know what letter represents that. Okay, so we know their prices and we know the total. So what does that tell us for our first equation? Basically, I have $58, 58 times the floor, plus 49 times the balcony, plus 34 times the mezzanine. And that's all going to equal $67,264. So far, so good? Okay. Next to get tricky here. There were 370 more main floor tickets sold than balcony and mezzanine tickets combined. What in the world does that mean? There were 370 more main floor tickets sold. So what do we have? We know we've got balcony plus mezzanine, right? Balcony plus mezzanine. But what happens with this 370?
Well, it'd be F plus 370.
Is it F plus 370 on this side equals this?
No, it's plus 370 equals F. Or is it not?
Would it equal 370?
There were 370 more main floor tickets sold than balcony and mezzanine tickets combined. That's the trickiness of this thing. What happens with that?
Would it be 370 minus?
So what do we know about main floor tickets? 370 more than the balcony and mezzanine tickets. Do we add the 370 or do we... What was it? Add it to where? So would we have floor equals balcony plus mezzanine plus 370? Would that work?
Yeah.
Okay. That would probably end up being our best thing because remember we're adding 370 because it's more than the main floor. Okay? Now can I take this and just stick it right over there? I need to move my balcony over and move my mezzanine over. So really I'm going to have F minus balcony minus mezzanine equals 370. We okay with that part? With what I did there? Yes? Okay. So that takes care of that one. Now we got one more equation. So we got to have three of them. The number of balcony tickets sold is, this is kind of nice to us because what does is mean? Equals. So we can say the balcony is 42 more than 2 times the number of mezzanines. What does that mean? 42 more than means what? Add. 2 times means 2m for mezzanine, and so that would be my piece for this one. So again, I got to move my 2m over. So I have balcony minus 2m is going to equal 42. But what do I have about the main floor in this one? Do I have a main floor? 0. 0 for my main floor because I don't have any there. And that's a matter of plugging it into your calculator. Okay, and having your calculator kick out how many of each ticket that you happen to have. So, put it on there. See what we get for an answer to it. I think this one shows up in 8.6. I got a couple of these that show up in 8.7. I just didn't label them because we were doing them all in the same manner. So, I think this next one is 8.7, but This one would not have been much fun to do by hand. And by putting the letters of F, B, and M in there, you automatically know what ones you have for answers. So, are we there yet? Yeah?
Trading floor goes 817.
Okay.
Property goes 312.
Mm-hmm.
And then the medical equals 135.
135? We all agree?
Yep.
Yes? Okay. Alright, because if I go back and I try these things out, they're going to come out to be the correct pieces in there. Yes or no? We all good? Or are we not good? We're good? Alright. Okay. The next one is the sum of three integers is 158. So what does that mean? So integer 1, integer 2, and integer 3. Integer 1's x, integer 2 is y, and integer 3 is z. So we don't have to get real fancy with these guys. So we know that x plus y plus z equals 158. Good first sentence, right? The sum of the first and the second exceed the third by 96. What in the world does that mean? The sum of the first and the second, so x plus y, exceed, what does exceed mean?
More than.
More than, okay. So it's greater than the third by 96. So if I add these two together, they're going to equal z plus 96. We okay with that part? Okay. Now how do I get it under here though? I would have to minus a z from each part. So that leaves me with x plus y minus z is equal to 96. So that's that part. And then we need to do this one. The third integer, which is the third integer? Z is, great good old is, 93 less than the first. What in the world does that mean? X minus 93. Okay. So how do I get that? So it can go underneath here so I can put it into my calculator to work with it. So I'm subtracting an x. So negative x plus z equals a negative 93. So negative x. What about y's? Do I have any y's? Plus z is equal to negative 93. So I have 0 y's, so I need to put a 0 in there to hold that y's position. Okay? So what will each of these things end up equaling? So what's x and y and z going to be? So x will be, you may know? What was x? What was it? 124? 124. What's y? 3? What's z? 31? Okay. Alrighty. So that would be my answers. Okay. The last story problem. This one I know in my online classes I get all kinds of emails of saying, these pizza ones, I just can't figure these pizza ones out. So let's see what we can do with this pizza one and see if we can get it set up and what we have in here. A pizzeria sells 3 sizes of pizza, small, medium, and large. So that means our small, we're going to label what? S, yep. Our medium is going to be labeled M, and our large is, of course, L. All right. The small pizza sells for $7. The medium pizza sells for $8. And the large pizza sells for $11. One evening they sold 70 pizzas. So what does that mean? It means I have, they were busy, weren't they? I have S plus M plus L equals 70. And received $206 or $12. What does that mean?
S plus M plus L equals 16.
What do I gotta have in the 612 though? What do I gotta have with my S, M, and L? I gotta have the price, right? So it's 7S plus 8M plus 11L is equal to 612. If they sold 13 more mediums than small pizzas, how many of each size did they sell? So what does that mean? They sold 13 more mediums than smalls. S plus 13 equals M. Yes. So how do I get that underneath this piece? Because I got to have it under here so I can work with it. Minus S. Okay, so I have a negative S plus M plus 0 large is going to equal 13. And that's my pieces. Not bad. We kind of walked through it, so it's kind of like the other ones we just got done doing. It's not much different. So what do we find for the answers? How many smalls, mediums, and large did we sell? So my augmented one will be 1, 1, 1, 70, 7, 8, 11, 6, 12, negative 5, 1, 0, 13. And so that's the augmented part. Now realize these augmented pieces can go back to this by just simply putting that number in front of whatever your letters happen to be that they give you for those. And in Hawks it will ask you in 8.7 to put it back into its standard form, and this is what its standard form would be.
For negative 1, put negative 5 because it was S.
Oh, yep, negative 1, thank you. So when I would go back and check this, I would have found that I made a mistake when I, okay, yep, so I need a 1 there, not a 5. Okay, so how many smalls? You said 17? Okay, how many mediums? And how many larges? 23? Okay. If I add all that together, it better equal 70, because that's what I was supposed to have. Okay, good deal. All right, what do you think? You do these? Okay. Okay, 8.8. 8.6 and 8.7 were together with that one. 8.8 is graphing two inequalities. 4.6, back in a basic algebra class, in 4.6 was where we did this graphing at before. So if you need to go back and review anything, 4.6 is where we did graphing with two inequality, or with one inequality. And when we did that, we had some special things that were going on. We had greater than or equal to, And when we had both of these, we shaded, because this gets into the shading part of it, we shaded above the line. So we shaded above the line. So if we had this graph, we would shade above the line. Or if we had this graph, we would have shaded above the line, okay? And if you have a y equals some value, you would shade above the line. If you had x equals some value, that was where our line went up and down like so. Above the line is to the right of the line, okay? That makes sense? Okay. If you have less than or equal to, then what happens is you shade below the line. So in this case, if I have this line, I will shade below the line. Yep. If I had this line, I would have shaded below the line. You okay with that part? This is a positive slope. This was a negative slope when we took a look at those. And if you had a y equals 2, for instance, you would graph your line at 2. Now we'll put a less than in here. Y is less than or equal to 2. We would end up shading below the line. And if I had x is less than or equal to a negative 1, that would put a line at a negative 1. And I would shade, I don't know if I'm up far enough there, to the other side of the line. Okay? Yes? No? Maybe? Okay. And with the shading, when we did 4.6, we only did one graph when we shaded there. The other thing is you had to pay attention to what your line did. Because in lines, if you had less or greater than or less than with no equals, you had a dotted line. If you had greater than or equal to or less than or equal to, you had, so you had an equals, you did a solid line. And these are called the boundary lines in Hawks. A dotted line means it's not included in your answer. A solid line means it's included. And Hawks will ask you to pick which one you're going to use. And how you can automatically do that is just pay attention to your inequality, and if your inequality has an equals in it or it doesn't have an equals in it. Yes? We good so far? Okay. The other thing in Hawks is that they talk about a test point. And a test point is a point not on the line, that is to one side of the line. And what that test point does for you is if you have, let's say we have this graph, and my line's running right here, and I guess I need to give you an equation. I better do it. Y equals 1x minus 2. The negative 2, remember, was my slope, or not my slope, but my intercept. So it's crossing down here to negative 2. My slope said to rise 1 and run 1. I have an equals in there. And a test point that we could use was at 0, 0. So if I pick this test point, it's on one side of the line, and I put 0 in for y, I put 0 in for x, do I get a true statement out of this? And if I get a true statement, 0 is greater than a -2. Is that true? Yeah, so that's true. So then if it's true, I will shade where that point is at. If I had picked a point that was false, so if it came out to be 0 is less than or equal to a -2, then this is false, and I would not shade, so do not shade where the point is at. Okay, make sense? Okay. On your graphing calculator, if you get your equation solved, so in here you're going to solve the equation for y, because then in your graphing calculator you can use your y equals and put in your equation. Use your over arrows to over arrow beyond it, because within your, on your graphing calculator, if you get beyond this point, there is a piece over here that tells you what your line is going to look like, whether your line's just a solid line, whether it's dotted. If you keep entering when you're in this spot, you will eventually run across a graph that looks like so. This is a greater than. If you arrow down one more, you will get a less than. So you can put those into your calculator, and your calculator will show you what side of your graph is shaded. But you gotta solve it for y. So you can't use those if you don't solve it for y. Are they very much help in Hawks? Not really, because if we go in and take a look at what Hawks does with stuff, so let's go and do that, because that's your basis of what we've got here. So we're going to go into 8.8. Maybe we'll go into 8.8. And if we go into their practice, it'll give us an idea of how Hawks is going to do these, and they do them a little different than just going through and doing that. Notice in your, let me get this keypad out of here. Within your Hawks, it's got a lot of different pieces here that you have to do. One is, of course, dealing with the very first equation in here, and it asks you, is it going to be a solid line or dotted? Or dashed, and what they say. So it's going to be solid, so we're going to click on solid. Then it says enter 2 points on the line. Oh, so what in the world does that mean? Well, if I go back, let me write those two down on my piece of paper over here. Y is less than or equal to a negative 5x plus 10, and y is greater than x minus 2. And let me shrink this guy and that one. And if I go back to this, and it says 2 points, what's my two easiest points to find?
Like 2, like, right? Well, 10 and
So if I'm working just with this one, and I gotta find 2 points.
0 and 10.
So my easiest points to find are the y-intercept, and that happens to be when x is 0, y is going to equal some value. So what happens here is I just simply put y, or put 0 in where x is at, and make it equal. So y equals 0 times a negative 5 plus 10, or y equals 10. So my y-intercept is 0, 10. And the other one is my x-intercept, because my x-intercept is going to be x, 0. And it's easy because now I got to do is take my original equation and put 0 in where y is at. 0 equals a negative 5x plus 10, minus 10 from each side. Divide by a negative 5. And I find x is equal to 2. So then I have my point, which is 2, 0. And so there's my 2 points that I can enter in. So your easiest way to find 2 points that Hawks is asking you for is to use these intercepts. Okay? So we did that a while back of finding intercepts in there. Okay, and while I'm here, I'm going to find my other one because then I don't have to flip back and forth because it's going to ask me for that one too. So I'm going to put in 0 for x, and when I do that, 0 goes in here, and I find out that I have a -2. And then if I put 0 in for y, 0 equals x minus 2, add 2. I'm going to find out that 2 is equal to x, so I can put 2 in there. And so I found both of my 2 points that I need to work in Hawks. So let's go back over here and get my Hawks to come back up and plug in my answers. So for the first equation, that's this one, what am I going to put in there? So I'm going to put in 0, and then I'm going to put in 10. And my second point is going to be 2, 0. And when I get off that, it graphs the line for me, so I don't have to worry about graphing it. But make sure you put your right points in, because it will give you a wrong answer. What side am I going to shade? Well, I've got a less than, so if I've got a less than or equal to, I'm going to shade A or B. Which one? Shade A, because I'm going to shade below the line. Now, if I wanted to, I could use my test point as 0, 0. Plug 0 in here and 0 in there. Is 0 less than or equal to 10? And that's true, so I know for sure A is. Hit submit, and if I get that out of there. And it tells me I did a good job. And then it's going to go through and pop up the next one.
Mr. Minky,
Yes.
on that first equation right there, it says y is less than or greater than,
Uh-huh.
and the other one is y is just greater than.
Yes.
So there's two different signs. Do you always look at the first equation?
Yeah, because it gives you right up here in Hawks, it'll give you the first, it'll give you that first equation. I can't do it now because we've already solved it, but it'll work with the first equation first, and then it'll go and work with the second equation. It'll only do one at a time, okay? So that's why I wanted to show you what was in here. Do I pick a solid or a dashed line? Dashed, because there's no equals. We solved our 2 points before, and we had 0 and a -2. And we had 0, or no, we had 2, 0, right? Okay. And it put my dashed line in there. What side do I shade? Because I've got a greater than, I'm going to shade C. And if I put my test point 0, 0 in here, 0 is greater than 0 minus 2, or a -2. 0 is greater than 2, so I know C is my correct part to shade. And then I hit submit. And that's correct, so I say OK. And then finally, Hawks will take those 2 pieces and put them together, and then you need to decide what side is the answer that you pick. Now, the thing about this, when you're graphing these two, the one that you're going to pick is always where you got the double shading. Don't pick C and don't pick D, because those are not where double shading's at. So these letters hop around in Hawks, and so you pick B and hit submit. And so you get your answer, and your equation is done. Does that make sense? Okay. Let's see what next one pops up here. Same type of thing. You've got your equation here. We're going to do a solid or a dashed. Which line would I do? A dashed. Okay. Then I got to enter 2 points, and again I'm going to do my 0 in for x. So if I put 0 in for x up here, that's gone. So what's y going to be? 7. And then over here, if I put 0 in for y, what's it going to be? 0 in for y, I'm going to get 35 divided by 7 is 5. Okay. And then there's my line. And then what side is shaded? It is A is going to get shaded? Okay. put your 0, 0 in for your test point. Be careful with this one because this isn't solved for y, okay? So 0 in here and 0 in here is 0 greater than 35, or 0 less than 35, yeah. So I can pick 8. Points are handy to use in certain situations. So submit it. Okay. But my next graph that they give me is kind of strange because it's an X. So what do X's usually tell me? What kind of line should I have? Vertical. And because this is an equals, I have a solid. But what about 2 points? So if I have an X connected to this thing, my X value is always going to be 3 on each of these because it's going to be a vertical line going up and down. Does it make a difference what I pick for Y? No. No. So I can pick 8 and I can pick -3 and it will give me my line, okay? Now, what side's going to get shaded? It is a greater than, so I would shade this side. Or if I use my test point of 0, 0, is 0 greater than a negative, or greater than 3? No, so that automatically, here's 0, 0, that tells me it's not the one I need. So I need D, submit it. And it's going to show me them both together. Should show me them both together. So each one of these problems is like 3 pieces to it. So be aware of that. So what would I pick for my answer? A. That's probably the easiest part of the whole thing is to pick out what you got for your final piece. Alright? Your test questions will be like this too. So they will be in 3-parters like this thing, where you got your pieces at. And then it gives me another one. I think we're okay. Let's skip this one because I wanted to get one that's got a y equals, or y is greater than or less than some number. It's not letting me skip for some reason. Should let me skip, but for some reason it doesn't want to. There we go. In this case, what happens? Do I have a solid line or a dotted line in the first one? It's going to be dashed because there's no equals. Now, if I've got a y is less than 2, what does that tell me?
Y equals 2.
Yeah, it tells me every time I am going to have a 2 for my y value in here. So what goes in the first part? Does it make a difference?
No.
Nope. Put a 6 and put a 0 and it gives me this. Where am I going to shade? It is a less than, so I'm going to shade where A is at. Okay, if I use my test point, is 0 less than 2? Yes. So I know I did it right. And then let's do the other one too. So the next one,
Y is going to equal -4.
yeah, once it gets up here to let you put stuff in. Solid line, y is going to be a -4 in both cases. So when they give you these are kind of nice to have. Anything for x. And side that gets shaded is greater than, so I'm going to shade where? C. And if I check it, 0 is greater than a negative, or equal to a -4, so that's correct. And then finally, pick the piece that's shaded. And what becomes shaded is, let's see if we get there, is C. Okay? Make sense? I think you can handle those, can't you? Okay. All right. Okay. So we will and I think we're okay. So I'm going to pause it.